morning, good day geometry. First objective of 2022 is a PO17. Also kicking off our next unit. And this unit is going to be all about triangles. And we're going to talk about a lot of the relationships that triangles and parallel lines and that kind of stuff have. So I actually like this unit a lot. It's a pretty fun one. And I hope you think so too. But anyway, we're going to start by classifying triangles by both sides and angles. You've heard all of these words before, probably. I'd be surprised if you hadn't. But it might have been a couple years. So what is a scalene triangle, and how would you label it? Scalene triangle. Jake?
Is it like a very uneven triangle?
Yes. What do you mean by that?
Triangle where none of the sides are the same length, none of the...
That's it. Okay. So a scalene triangle has no congruent sides. Okay. And need to calibrate there. This is not looking like a very good scalene triangle. Let me try again. Let me put like an obtuse triangle there. This is gonna be, oh my gosh. Hold on, we're gonna speed run calibration here. Get this. There. Okay, so a scalene triangle. Example might be like this. If I ask you to label one, it's not good enough to draw a triangle that looks like none of the sides are the same. It has to actually be labeled. So it doesn't really matter what the sides are. Make this 10, make this 3, make this 8. As long as you're showing that none of the sides are congruent. Okay? So there's a picture of it in words. No congruent sides. No congruent sides. How about isosceles? What does isosceles mean? Joey?
Two of the sides are the same one.
Two of the sides are the same length. Okay? So this one can be marked a couple different ways. You can mark it with numbers, or you can put the congruency markers in. Right? Because those markers mean those two sides are congruent. So you can either label a side lengths with actual lengths, with numbers. You might say this is 6, this is 6, this is 4, whatever, or you can just do the tick marks. But this will have two congruent sides. Okay? Two congruent sides. How about equilateral? Equilateral. Drake?
All sides equal.
All sides congruent. Okay? And again, for this one, you can use the markers if you want to mark each side congruent. Or you can label them 4, 4, 4, okay? But this is all sides congruent. And then which other triangle goes hand in hand with equilateral? Where if you have an equilateral, you also have an, James? Equiangular. So it's the same picture, but since we're talking about angles here, you can use it with the markers, the arcs in each corner there to show that all angles are congruent. Or, and we're going to kind of get into this today with some of our definitions, but what would each angle measure have to be? No matter what size an equiangular triangle, each measure has to be 60 degrees. Okay, because you may or may not remember that every triangle has exactly 180 degrees in it. And if all angles are equiangular, they're all congruent, they'll have to be 60. It's the only way for that to happen. Right? Acute. What's an acute triangle? Your elementary teachers probably drew a little triangle with a little smiley face in there. I'm not nearly that creative or that cutesy. What's an acute triangle?
Is it all angles are less than 90 degrees?
Yes, all acute angles. So let's see, we'll draw kind of one that looks like this, or like that, okay? If you had to label it, you would need to put in the angle measures here. So this one looks to be, I don't know, about 80 or so. This might be 60. What would my third angle have to be if my other two angles are 80 and 60? Well, 40, because it has to add up to 180. This is where sometimes kids get caught on a test. If I ask you to draw and label an acute triangle, if your three angles don't add up to 180, well, then it's not even a triangle. right? So I have to take the point off for that. So make sure that you are paying attention to what those measures are, not just that they are acute angles. So all acute angles. All acute. A right triangle, we've talked about these already with proofs. What does a right triangle have? What makes it a right triangle? Well, 90-degree angle. If I ask you to draw and label it, this is not good enough. What would you need? What are your two options? Drew?
Square in the corner.
A square in the corner, or you could draw the 90. You wouldn't have to draw the other two angles or label the other two angles necessarily, because a right triangle, its definition is one right angle. So you wouldn't have to put the other ones in there, but you do need either a 90 or a box in the corner. One right angle. And how about an obtuse triangle? Obtuse triangle. Well, one obtuse angle. So here's an example of obtuse triangle. Labeling it, we'll call this one 130. This one might be 20. This one might be 30. Again, our three angles have to add up to 180 degrees. That one obtuse angle. Obtuse. There you go. Angle. All right, questions on those classifications? No? Pretty much review? I would have ended so. So now we get to some more theorems and things going on here. So these are things that add to your ongoing list. If you've got a nice list already compiled, it's just, since we're covering them today, just add to it today. You don't have to wait till the end of the unit, because this unit's going to have quite a few of them. But the triangle sum theorem, theorem 4.1, says that every triangle has exactly 180 degrees. Exactly 180 degrees. And what we mean by that, that's not actually the way the theorem is worded. The theorem is worded much more mathematical than that. It says the sum of the interior angles of a triangle equals 180 degrees, but in kind of layman's terms, every triangle is exactly 180 degrees. And so if you are given a triangle, okay, and you're told this is 70 degrees, this is, we'll call it, I kind of already did that one, 80 degrees, okay, and you're asked to solve for angle 1. You're able to do that because you know that the sum of the angles has to be 180 degrees. What's the measure of angle 1? William? 30 degrees. So the measure of angle 1 equals 30 degrees, okay? How can you tell the difference between an angle measure in a triangle and a label of an angle in a triangle? Like, how do you know that's angle 1 and not 1 degree, or how do you know that's 70 degrees and not angle 70? What? Yeah. Right, because of the degree symbol. Okay, 80 degrees, 70 degrees, that's just angle 1. Sometimes I'll try and do it in various colors. You've got the black and white copy, so it doesn't come across to you, but you might see sometimes angle labels are a different color than angle measures. Okay. The corollary to the triangle sum theorem says that in a right triangle, the two acute angles add to be 90 degrees. In a right triangle, the two acute angles add to be 90 degrees. The word corollary kind of means like to go along with, kind of goes with the triangle sum theorem. But if you've got a triangle marked as right, and you know this angle is 50 degrees, the other acute angle has to be, anybody? Okay, just Peter. 40 degrees, right? I said earlier when we first started geometry that you can add the 90, 180, or 360. You pretty much got most of geometry already figured out. Here's some examples of that. Okay. Questions so far? Okay. An exterior angle. What does the word exterior mean? Exterior?
Outside.
Outside. So an exterior angle is an angle outside a triangle formed by extending a side of the triangle. An exterior angle is an angle outside of a triangle that is formed by extending a side of the triangle. So an example would be if we've got a triangle here and we've extended that bottom side, right? We've got angles 1, 2, and 3 inside the triangle. And then by extending that bottom side, we've now created an angle outside the triangle that we can call angle 4. Right? And that's called an exterior angle. Okay? And this is where some of the cool relationships with triangles start. Because the exterior angle theorem, what are some relationships that you can tell? This is what we already know. Dig in your toolbox a little bit. What can you tell me about the relationship of angle 4 with other angles within the triangle, the interior angles? What do you see? Like?
Angle 4 and angle 3 will add to 180 degrees.
Okay, and why do we know that angle 4 plus angle 3 will add to the 180 degrees? Straight line, do you remember what that's called? The LPP? Linear pair postulate. Okay. Anything else? Okay. So what the exterior angle theorem says is that an exterior angle is equal to the sum of the two non-adjacent angles. An exterior angle is equal to the sum of the two non-adjacent angles. So going from our same example that we just had here, what the exterior angle theorem says is that the measure of angle 1 plus angle 2 is going to be equal to the measure of angle 4. Those two non-adjacent angles, their sum is equal to the measure of angle 4. Anyone tell me why that is? Or why that makes sense? And we'll start by saying what Blake said, is that we already know that angle 3 plus angle 4 equals 180. Right? Angle 3 plus angle 4 equals 180. And we know that because of the linear pair postulate, which we'll abbreviate the LPP. Do you know?
If you were to add 3, or if you were to add 1, 2, and 4, you get 180.
Yes. Why?
Because
Well, no. Wait, sorry, I misunderstood. You won't necessarily get 180, but you do know that the measure of angles 1 and 2 is equal to the measure of angle 4.
oh yeah, because you need 3 to get to 180. If you add 2 to 4, you get 180.
Okay, which is what we have here, right? We have angle 3 plus angle 4 does equal 180.
And if you add 3 to angle 1 and angle 2, you get 180.
There it is. Okay. There's another way to get 180 here, right? Based on the triangle sum theorem, we also know that angle 1 plus angle 2 plus angle 3 equals 180. Okay? Because of the linear pair postulate, we know that 3 plus 4 is 180. They make a line, as Blake said there. And because of the triangle sum theorem, every triangle is exactly 180 degrees. We know that the three angles inside the triangle also add to be 180 degrees. And we can abbreviate the triangle sum theorem to be TST. I'll put in parentheses 4.1 here. We forget what TST stands for. Okay. And if we have two things that equal 180, or two things that equal the same thing, what do we know about those? If 3 plus 4 equals 180, and 1 plus 2 plus 3 equals 180, what do we know about 3 and 4 and angles 1, 2, and 3? Nathan?
Angle 1 plus angle 2 equals.
Not quite yet. We're getting there though. Do you see what we're kind of doing here? Are you picking up what I'm throwing down here? What are we essentially writing here? A proof, right? A proof. Okay. We know that because angle 3 and angle 4 equals 180, and 1, 2, and 3 equal 180, we can say that angle 3 plus angle 4 is equal to
1 and 2.
And 3, right? Because if both of those statements equal the same thing, we know that they are equal to each other. That's the definition of the, if two things equal the same thing, they're equal to each other. A equals B, B equals C, therefore A equals C. What did I just describe? Adam? What's that?
Addition.
Nope. Well, transit property. Okay. Transitive property. Two things that are equal to the same thing are equal to each other. Yeah.
So how does that help us?
Because what do we see is on both sides of the equation? Our new equation, what do we see is on both sides? Angle 3. And since we have the same thing on both sides of the equation, what can we do with it? Cancel it out, right? So we can say that angle 4 is equal to angle 1 plus angle 2. And what property allows us to take away the same thing from both sides?
Subtraction.
Subtraction property. Subtraction property.
Thank you, William.
Okay, so what we just did here was I told you what the exterior angle theorem was, right? That the exterior angle is equal to the sum of the two non-adjacent angles, but then we actually proved it using math.
Crazy.
Right? We were able to, some of us, if you're pretty familiar with all of our theorems, we probably will follow along. Say, oh yeah, okay, yeah, oh, gotcha. Right? But here's the mathematical proof behind it. And that's what proofs are used for. You make a claim and you back it up. And now that our toolboxes are getting fuller, getting bigger, we can do this more often here. Okay? Okay, questions on any of this? Okay, so looking at some of the examples down below, it says find the value of the variables. We are going back some algebra a little bit here. On that first one, K right here, angle JKM is our exterior angle. And then our two non-adjacent angles, angles J and L, are X and 70. What equation can we set up that allows us to solve for X? What's the relationship between the exterior angle and the two non-adjacent angles? We'll call this angle 1. We'll call this angle 2. Our exterior angle we'll call angle 4. Drake?
Because the exterior angles are equal to the two non-adjacent angles.
Okay. We know that because of the exterior angle theorem, angle 1 plus angle 2 is equal to angle 4. Right? That exterior angle is equal to the sum of the two non-adjacent angles. Angle 1 is marked with X. Angle 2 is marked with 70. Angle 4 is marked with 2x minus 5. And now we have an algebraic equation being solved. Hooray! Right? Yeah. So this can involve some variables on both sides, moving things around, blah, blah. But anyone have the answer to this? What's the value for x? Nathan?
75.
75 value for x? Have a second on that?
Yes.
Okay. So if you move x over, move the 5 over, add 5 to both sides, subtract x, you get x equals 75. Let's test this. If x is 75, put it in red. That makes this 75 here. 2 times 75 is 150, minus 5 is 145. Does 75 plus 7 equals 145?
Mm-hmm.
Yes, it does. So it checks out. Geometry is really easy to check your answers because everything fits. It's like a puzzle. Okay? Yeah?
Do we have to put the reason, or can we just?
No, you can just do it. Okay? The next one, what equation, we're kind of short on time here, so we're not going to go through the whole thing. But what equation can you set up that will allow you to solve for the variable in the next one? Noting it's a right triangle. So take a look at the top. What do we say about right triangles? What can we set up here? Someone we haven't heard from today, perhaps? A new contributor to the channel? I've heard from you. Heard from you too. Heard from you. All right, so we've heard from Mackie.
In a right triangle, the two acute angles add up to 90.
Okay, so how does that allow us? What equation does that allow us to set up here?
2x, and then x minus 6 equals 90.
And are we adding those two? You said the sum. 2x plus x minus 6 equals 90. Do we need parentheses around that x minus 6? We don't.
No.
Okay, there are parentheses around in the triangle, which is okay. You could add them here if you wanted to, but they're not going to change what you do. You know, since there's just you're not distributing anything. Since this is a plus sign, not a minus sign, you don't have to worry about that. So they're not necessary when you actually put them in the equation. But you can you can solve the rest of them. Right? Your homework for tomorrow is from your textbook. So no device needed. Isn't that great?
So awesome.
I would like you to do on page 221. Let's do 1 through 7. And then 14 through 19. We're still only at 13 questions. That's not so bad here. And then how about 21 through 26? That's all. Okay? 21 through 26. No, sorry. I keep telling myself, take this one out there. Do you know what those markers mean there? Anyone know? Yeah. So those markers mean parallel lines. We haven't talked about that yet. We are going to shortly, but you can skip that one. Don't worry about that one. Okay. All right, folks. So for tomorrow, there it is. That's my math. Happy 2022, everybody.